So the session is covering about handling qualities lecture. The topic, hopefully, that we could cover, as I said, is Cooper-Harper rating scale. Now, the background why, obviously, you need to study or you need to know about the handling qualities and flying qualities. So I'm going to talk about also flying qualities later on. Hopefully you could see the difference between handling qualities and flying qualities, which probably you will hear that or see that or read that a lot, those two terms, which is handling qualities and flying qualities. So the background is obviously as a designer, you need to provide your aircraft, which you're designing, with an optimal performance. Now that regard to the stability, we talked about stabilities already last week. There are two stabilities, static stability and dynamic stability. Now, when we talk here further on about the stability, it means like both, which is static stability and dynamic stability. And of course, in order to make your aircraft have an optimal performance, you need to control, you have the controllability, which is obviously then by default, it means that you need to provide a flight control system, right? So this is to ensure that you have safety of flight. Then of course your aircraft responds well as you expect it to behave, say, acceptable response. And of course, to complete the mission, whatever the tasks or missions that you try to achieve with your aircraft, either rolling or climbing, descending, takeoff, landing, and so on and so forth, right? So this is obviously the evaluations of handling qualities and flying qualities is quite important in this case, right? So now the terms, as I said, handling qualities and flying qualities could be considered equivalent, but you could read that yourself about what actually the handling qualities is about. Now, handling qualities sometimes refer to the aircraft short response, regardless the pilot workload, obviously. Now, this is something about how your aircraft behaves after last week we talked about the perturbation, the disturbance, for example. So the focus will be on the aircraft design, concern on design of the flight control system, how well that if there is a disturbance, for example, dynamic when your aircraft going into a dynamic motions, and then obviously you don't want that happens for some times, obviously, then you try to handle it either manually by if you as a pilot, you try to handle it by taking over the control, the control column or the joystick that you have in order to stabilize your aircraft to back into the equilibrium condition, for example. Now that is the behavior of your aircraft, including your flight control system characteristics, is part of the design of your aircraft. Now the assessment obviously is termed as the handling quality assessment. Now, flying quality is sometimes referred to the aircraft long-term response. So they also take into account the pilot comfort and workload. So how much effort the pilot need to, put into making the aircraft, for example, stable again, then that implies also back to the first definition, that refers back to how good your aircraft then take that stabilizations effort, as well as also how good your flight control then take the command and then execute the command, for example, like moving the elevators, moving ailerons, or moving all the flight control surfaces that needed in order to stabilize the aircraft. Okay, but bear in mind, as I said, many books, the terms can be considered equivalent to some extent, and sometimes used interchangeably to describe the general aircraft response characteristics. So when we talk about handling qualities, sometimes people also include the flying qualities, and sometimes when they talk about flying qualities, sometimes they also means handling qualities as well. So to describe the general aircraft response characteristic with respect to the given inputs. So when the pilot gives an input to stabilize the aircraft, then the easiness to fly in order for the pilot to complete a task or a mission. Okay, I think that is quite clear in that definition, so you can read that by yourself. Now, I took two diagrams from Mike Cook books, Flight Dynamics Principles. The two qualities, as you can see, are very much independent, but in practice, as I say, is probably inseparable. That's why people sometimes use it interchangeably. Now, the flying qualities may be regarded as being task related, whereas the handling qualities may be regarded as being response related. But whatever it is, as you can see, the flight control system now become obviously typically important, because both handling qualities and flying qualities, as you can see from those diagrams, the two diagrams, the flight control system are typically augmenting the loop in this case, if you can say that as a loop. So, for example, like the pilot obviously give an input. This is first of all, this is two different kind of like type of aircraft, in a way that this is a conventional aircraft. But of course, in modern aircraft nowadays, they use computers as part of the system, which we refer to that as a fly-by-wire aircraft. But more or less, they are doing the same. If we talk about the flight control system, you can see that a flight control system is part of the loop there. The pilot gives the input to the aircraft, then obviously the aircraft will give a response, for example, and then the response take back into the flight control system, and then obviously it will be fed back to the aircraft in order to do the stability. And that the loop there is obviously the handling qualities that we talked before. But then when you include the task, then that is how good then you achieve the task, how, in terms of whether you achieve the task completely in perfect score, for example, then that related to the flying qualities. Now, if we talk about the fly-by-wire, you know that the fly-by-wire in modern fly-by-wire aircraft, the flight control system is usually integrated with the stability augmentation system, which obviously inside of that there's a computers involved as well, and because sometimes computer takes the authority to execute the command, for example. So now here, the flight control system becomes an integral part of the primary signal flow, rather than pilot gives directly to the aircraft like the first one here. It's then intermediate, the media that as an intermediate media there is the flight control system. The flight control system then influence the dynamic characteristic of your flying quality as well, which is also important in this case. Okay, so I hope that just gives you an idea how the handling quality and flying quality is about. So if it's about mission task, then that what we call it about the flying qualities. But as I said, later on you understand that when we talk about handling qualities, Cooper Harper rating scale, for example, then that is also something to do with the task as well. So handling quality is about your response of your aircraft, then how you achieve the task, how you could complete the task, then that's also maybe regarded as also handling qualities and flying qualities of your aircraft. Okay, now obviously motivation, I'm not going to talk this in detail. I will not take a long time to look into this slide, so you can read it by yourself. So I think the next slide is also about a bit of history, which I guess is not really technical things that we need to discuss further, but you can read it by yourself. But obviously, as you know, that good handling qualities are the key and critical enabler to the maximum effectiveness of your aircraft. Now, you know that when we talk about how the pilot complete the task, is about how he or she controls and stabilizes and navigate the aircraft. That's why the issue associated with stabilizing and steering and navigating, obviously, it's then very much related to how good the handling qualities that could be performed or could be conducted by the pilot. And now, when we talk about to do something, for example, to complete a task or a mission, then obviously then you also need to or want to see how much pilot need to put an effort in order to do that. So obviously good handling qualities obviously could reduce the pilot's workload, allow him or her to focus on his or her operational roles. Then obviously we talk about safety of the flight already, so it can be related to safe operation. Okay, now as you could deduct from that, is a flying an airplane with poor handling qualities is a risk. Okay, so no questions about that. Now I'm going to skip this. This is a bit of history. You can come back and read this if you want. I'm going to start about this as the first attempt, let's say, to what this just comes together at the Cooper Harper Ethics Sale, which we're going to talk about and see afterward. But as we know, we have several aviation agencies now established by most countries. For example, in these agencies obviously to oversee the aeronautical activities in their nation or in their territories, as we know. For example, like UK, we have CAA, right, to regulate all non-military aviation, and of course the Ministry of Defense, MOD, to oversee all military activities and others. Of course, we have EASA, which refers to, you know that already, CS25, you know, the document that you look always all the time in aircraft design is basically published by EASA, which is a European Aviation Safety Agency, which for the past few years back, obviously UK is part of that in order to you know, to seek the regulations or the standards in aircraft design, for example. And of course, in the US, you have a FAA, which is counterpart of the EASA, Federal Aviation Administrations, which is the US government authorities, or US government bodies. Now, all those agencies basically issues documents which specify the minimum acceptable standard of flying qualities, right, in some detail. Now, obviously, it's what we nowadays call it as a flying qualities requirements. The flying qualities requirement issued by the MOD, which is from the US, and also in UK. Well, in UK MOD, and obviously in US DoD, Department of Defense, specify each much greater detail. That is a bit of history as well. So why then we use military standard? In this case, if you remember, when we talk about designing the flight control surfaces in aircraft design, we use MIL F8785C, which is a military standard. Now, because of the historical you know, story about that the military requirement, they have much greater detail in every respect. Okay, sorry. Now, is this responsibility of you as a designer or a manufacturer then to demonstrate that your aircraft complies with the appropriate specification prior to, you know, to deliver your aircraft or acceptance by the airliners or by the operators. Okay. Now, obviously, the goal of handling qualities, I think this is very clear. Handling qualities is used to create connections between the pilot opinions and the design of the aircraft. Later on, you will see, for example, the Cooper Harper rating scale. On the left side, when you see the flow chart later on the left side, you see the pilot opinions. And then on the right side is the scale, the rating scale. So then you cannot differentiate or you cannot separate the pilot opinions in this case. Now, you will see later on why it is quite challenging when you try to assess the handling qualities, because you can see that you need to ask the pilot opinions. Now, asking people opinions, as you can see, is quite subjective, right? So, well, we're going to talk about that later. So, the handling qualities, obviously, how you know, the pilot could perform the tasks associated with, you know, to manage. Again, manage means stabilize, control, navigate, right? So then obviously if there is a disturbance, turbulence, and so on, how he then or she then deals with that issue, right? Now, of course, from all of those slides that we've seen, the diagrams, you know, the loops diagram that I've shown you on a few slides, that is very much related to, first of all, the aircraft design. So how you do assess the static stability, the balancing, and so on, how you design the aircraft aerodynamically and so on and so forth. And then obviously how you design the flight control system. And when I say autopilot here, it means that not only the autopilot, you know, the computerized flight control system, but of course, flight control system in general. So how you then, you know, sizing your aileron, sizing your elevator, and so on and so forth, right? That is because very much related to the response of your aircraft. You for those of you who design the aileron flight control system, for example, knows that why then we refer to a military standard 8785C document, right? So now, in order to do that, obviously could I just remove this because it now becomes, so the generalities of this. Then if you look at the Cooper Harper and also the military standard later on, then usually they use level. So I think you know that already when we talk about the design of the 8785C using 8785C documents. We have like 3 levels, level 1 being the best one, say, and level 2 is kind of like in the medium rating, and level 3 is obviously well, let's say the worst one, because that requires, as it says here, excessive pilot workload. So in order to stabilize your aircraft, for example, the pilot need to put an excessive workload. They need to be very busy in order to, you know, to overcome or deal with the issues, for example, like a threat. If there is a threat, I'm saying threat here means like turbulence or gust, for example, issues. But of course, if in a certain condition, when you are asked, or if you are a pilot and you are asked to do a certain task, I keep mentioning in the tutorial session, for example, in flight sim assignment later on, you are asked to check your handling qualities when you try to hold your bang angle 30 degrees, for example. Now that is a very simple task, basic task, obviously. Like banking your aircraft in 30-degree bang angle is not really like a big issue for a common pilot, obviously. But of course, how hard it is, you could measure it, right? How difficult, well, in terms of the pilot workload, how much pilot workload, how much effort that pilot need to put in order to do that, that is something to do that you need to assess. And then how good your aircraft as well to achieve that 30-degree, that is something related to what you could associate that with the level, right? Either level 1 later on or level 2. Even if it's worse, then it becomes fall into level 3 categories, right? Now you know that 8785C using these levels 1 to 3. But of course, later on, when we look into, I think on the next slide, you will see that the Cooper Harper rating scale, it used scale from 1 to 10. But of course, in here, you could kind of like address that, well, Cooper Harper scale from 1 to 3.5, you could consider that as a level 1, sorry. A Cooper Harper scale from 3.5 to 6.5, you could consider that as level 2. And then Cooper Harper scale from 6.5 to 10, then you could consider as the worst, which is level 3. But you will see that in Cooper Harper rating scale, which we then obviously you are advised to use it when you assess your flight sim assignment later on. Right. Now, of course, we talk also generalizations about how the task is classified, right? So now they classify that into phase A, phase B, and phase C. You will see on the next slide, obviously. Phase A is considered like a non-terminal flight phase, rapid maneuvering, for example, precision tracking, which is really need a certain focus of the pilot, like the flight path control, air-to-air combat, ground attack, terrain following, for example, which probably is not really much related to a commercial passenger jet aircraft that you're designing at the moment. But of course, there is a phase B, which is non-terminal flight phase, gradual maneuvers, non-precise tracking, may need precise flight control. For example, when you try to do a cruise, obviously. But of course now in modern aircraft, the crews, obviously the aircraft is always using an autopilot system to keep the aircraft in level altitude, for example, to do the climb, descents, and also turning, loitering, holding pattern, for example, to keep a holding pattern. Of course, there is a level C, which is now related about takeoff and landing. So a task obviously is defined as the actual work assigned to a pilot. Now, later on, you will notice when you do your flight sim assignment, the task is very simple. It's not like asking you to do a landing and takeoff, for example, because I've seen your assignments already that you do, for example, like turn hold or pitch hold, bank hold, which I mentioned earlier, which is a very simple task. But of course, now you need to assess how good your aircraft plus the pilot, obviously. When you do the bang, you include the pilot inside as well. How good your pilot and the aircraft conduct that task, meaning like when asked to bang 30 degree, it will then bang your aircraft 30 degree with a tolerance. Obviously, you could include you could introduce a tolerance in there as well. Now, obviously, if I could just conclude this, then you have when you do define the task, you need to make sure that the task could be performed by any pilot involved in this flight test. Obviously, of course, if you conduct like a very if you define when you try to assess handling qualities, then you define a task to be conducted by a test pilot, which only a certain test pilot could do it. Then obviously, then the assessment will not be objective, right? Will not be fair, because obviously, say beginner pilot, for example, could not achieve the same level as the experienced pilot, for example. So that's why it's very simple, very important when you define the task, what tasks need to be assessed. It's very important to keep the task is, well, let's say simple, meaning that all the test pilot that you involve in that flight test could do it without any discrepancies or without any big difference between one and another. Okay, let's see about the Cooper-Harper rating scale. Now you can see this here, that when we talk about rating scale, I think it's the next slide, is it? Yes, but I'm going to talk about this first. As you can see later on in the next slide, pilot opinion is inseparable. You cannot really differentiate, well, separate between what a pilot thinks about the aircraft plus the flying qualities and handling qualities the aircraft then eventually produce once the task is conducted or is performed, right? So in this case, pilot opinion rating scales, then you could use that as one of the tools to determine the quality of handling of your aircraft. Now, one famous pilot opinion rating scale is this Cooper-Harper rating scale, right? So, I think, Cooper-Harper rating scales. Let's, if I could just say what actually, who they are actually. I think Cooper is a test pilot, NASA test pilot, George Cooper, I think that's his real name, full name. He's test pilot. So initially started his kind of like assessment based on his, his rating based on his opinion in 1950s, late 1950s, and then after that, the research Calspan, which is the in California, NASA Calspan Research Lab, someone called Harper, Robert Harper, I guess. Then he modified that together with the Cooper as a test pilot to then establish this kind of like flow chart. As you can see, it's a simple flow chart, which you can see the bridging or connecting what pilot says about the aircraft. As you can see, this is more or less like pilot opinion, and then try to bridge that, try to connect that into a numerical scale. As you can see on the left, on the right side, sorry, there is a numerical scale from 1 to 10, as I mentioned. So as you can see, the rating scale is bridging between the pilot opinion into a numerical scale system on the right. So now, this is a few challenges, obviously, you need to consider, because, as I said, carefulness need to be taken, since the qualitative, because this is then qualitative assessment, right? So pilot opinion, but this is then quantitative assessment. Now, the qualitative assessment here is very subjective, as I said. For example, like, is it controllable? Maybe this is very simple one. Is it controllable? You know, a beginner pilot say yes, it can. Obviously, the experienced pilot, yes, I can control the aircraft. But now comes to the whether is adequate performance attainable. Then with the tolerable pilot workload, then different pilot could say a different thing, right? So beginner pilot say, oh, I need to do this, I need to do that. So it's quite busy for me to do this. But the experienced pilot could just simply say, yeah, that's fine. I could do that easily, for example. So that's why when we do this later on in your flight sim, we try to make it simple. For example, like bang angle hold, heading hold, the pitch hold, or whatever, which hopefully any simple inexperienced pilot could do that, and then give an opinion in the case whether it is controllable, or is it you need to do it an extra work or something to attain that 30-degree hold. And then of course then with related to the satisfactory of the without any improvement and things like that, then that is something that you need to assess as well. Some people say this is a bit of a dark art or imprecise art between how you connect what people think or pilot opinions into a scale, which obviously people can go on a different opinion, or can go or can have a different rating scale at the end, obviously. So, but hopefully by using this, you could have a basic assessment of your handling qualities of your model, hopefully in the flight sim. Okay, right. So now, of course, that comes into a few terminologies, or a few. If I could just go back, then you see that there is something to do with the performance, right? And then also demands of the pilot. Now, this is obviously the pilot workload. Now, this is the performance of the aircraft, right? So this is, if you could connect that, this is really something to do with the design, how your aircraft designed properly. In this case, when you do with your model, how your model, the fidelity of your model, how close it is to the real one, that then will obviously define this kind of like column in this case. And how good your pilot conduct the tasks, in this case, for example, like a bang angle hold, then related to this column here, which is the pilot opinion. So in this case, the definition, for example, like controllable, you need to be carefully understand properly. For example, when it says controllable, for example, aircraft, it means that you must be able to retain control in all mission tasks without losing effort and attention to other duties, for example. And of course, when it says performance, when it says adequate performance, for example, it allows you to achieve the task. That's why I think Johnny, for example, like choose the task is very simple. For example, bang angle hold 30-degree. That is a very simple task. And obviously, the question here, how good your aircraft to achieve that 30-degree bang angle? I think I mentioned a few times already, if it's not in your tutorial sessions, when you do that, perhaps it's good to see, for example, a record of the bang angle, obviously. If you could just put the time history of your bang angle as pi, for example, at 30-degree, for example, here. And then let's see how good your aircraft then perform that to hold it at 30-degree, right? Now, in order to do that, you could as I said, make a tape or something, or a band, let's say, plus minus, I don't know if you talk about band angle, because I give an example here, when you do a vertical landing, obviously, which is not going to be conducted in your assessment later on. For example, let's say if you put like 3 degree plus minus, and you could say that is the desired, right? But when it's plus minus, say 5 degree or maybe 10 degree, I think 10 degrees too big already, 5 degrees, say, then you could just say an adequate. So you have like 2 bands on that, which is if that your aircraft could be maintained within 30 degrees most of the time, for example, you could consider that as you achieve your desirable performance. And then obviously within 5 degree plus minus, for example, then you could consider that as your aircraft able to maintain an adequate performance, for example, something like that. So now, of course, this is about the performance of your aircraft. Then it's very important also, because when we talk about Cooper Harper, that is about your aircraft characteristic. But then you need to ask also the pilot, well, not to ask the pilot, but at least to assess also how busy the pilot is to conduct that 30-degree bang angle, right? Now, of course, when I mentioned about looking into the pi, which is to see how good your aircraft to achieve that 30 degree, but you need to also then look into how busy your pilot is by looking into, well, maybe look into the joystick. I don't know, maybe you should be able to read the joystick reading if you either working on a Merlin flight simulator or explain how busy the pilot is, for example. You could see that maybe there is a condition where you could see, oh, the pilot could maintain that 30 degree nicely with an adequate performance, but when you see the joystick, he's doing it quite busy, doing like that, which then you could consider that as a pilot need for example, like an extra load. For example, if you go back to this let's say the Cooper Harper rating scale, when it says adequate performance, yes, it could maintain 30 degree, then you go into that, yes. Now you say, is it satisfactory without improvement? If there's too much pilot to do some improvement, it means like the quite busy, moderate pilot compensations, considerable pilot compensations, or extensive pilot compensation, then it comes to whether you put it as a rating scale 4, 5, or 6, for example. But if it is still satisfactory without improvement, you still need to rate that into whether desired performance, not a factor, and then minimal pilot compensation, and so on and so forth, which I eventually need to put that into a scale 1, 2, or 3. Okay, so that is which I mentioned earlier in the class, that you need to consider. Not only looking into this, you might need to also look into that. You might need also look into the reading of altitude when we talk about conducting the task of bang angle, for example. Then you need to, if I could just put the my camera. So when you do the bang angle, it's very important. Coordinated bang angle is important also to look into whether your aircraft slipping or skidding. So you might need to also check your altitude reading as well, whether you drop your altitude or even increase your altitude. Okay, so it have to be. I think that is perhaps that's a better way to make sure that the performance is being achieved, right? The task has been achieved. Because if you drop the altitude, it means you don't complete your task properly, because the task is asked you to hold the bang angle with a certain 30 degree without slipping or skidding. Okay. Now, obviously, again, a different some other terminologies, some other terms here is compensation, is the measure of additional pilot effort, physical and mental. I'm not sure whether mental is now is being assessed as well after you do that test, because obviously you do it in flight sim. There's no mental pressure in there, but if you do it up there, obviously there will be a mental pressure, because if you do it wrongly, incorrectly, that could, you know, put your life at risk, and then put everybody's at risk. Everybody's on the airplane at risk. Okay, so that might be a mental pressure as well. But obviously, we talk about physical effort, pilot effort or pilot workload. Here is about, when I say about joystick reading, for example, how busy is your pilot doing that simple task. In this case, it's quite a simple task, right? Not like military pilot, for example, have to drop a certain well, for example, if you need to drop a bomb, for example, a certain precise location, that is requires more than only bang your aircraft to a degree. A satisfactory performance. So that is one. It says satisfactory means like it's good enough to meet the standard. Then it need no change, no require. So again, if it's 30 degree, then it's 30 degrees. So you don't need to do different things to achieve a 30-degree bang angle. And of course, an unsatisfactory is the opposite of that, obviously. Right. So now I think this is just like what you need to do. But of course, a few points in here you don't really need to think about it. But obviously, when you try to assess this, you need, as I said, you need to define the task. What sort of task? Now the task, hopefully, that you could, when you define a task, it has to be non-subjective, meaning like experienced pilot, non-experienced pilot could do that without any difficulties, right? If you define a task, do this, only a certain pilot can do it. And obviously, when you try to assess with the test pilot, which is inexperienced, they might find it difficult, which is obviously then that will affect the rating scale that they put up in the Cooper Harper rating scale. But if you ask the experienced pilot and they say, yeah, I can do that with hands, well, with closed eyes, for example, with blind eyes, then the rating scale that he or she put then obviously will be different from the previous one. Okay, but in this case, of course, when you do the flight sim assignment, the task definition, you don't need to worry about that, because Johnny already mentioned that in the assignment brief. Bank hold, pitch hold, altitude hold, for example. So now the task, well, the thing that you need to decide is what I said, the task tolerance, right? So when we talk about this, how then you decide the band, for example, the desirable, the adequate band, how much it is, then you need to be wisely as an engineer. Then you need to define what those task tolerance. In this case, for example, maintaining plant position with ground speed 135 with the wind 25, for example, then you decide the tolerance about plus minus 2 meters, for example. Then obviously after that, the workload assessment need to be assessed, whether it's difficult to achieve, and of course, what the pilot effort required in there, and then of course you assign the scale, right? So if you go back to this Cooper Harvard scale, this is what the pilot should tell you. Is it controllable? If it is yes, then it goes to that. Is adequate performance sustainable? If it is yes, it goes that. If it is no, then you have to kind of like define the deficiencies in there, whether they're major deficiencies with adequate performance, considerable pilot compensations, intense pilot compensation. If it is goes yes, then obviously minor deficiencies, then you could then need to consider that as well, what actually rating for that. And then obviously if it goes in there, the rating will be 4, 5, and 6. If it is already goes into here, then obviously the rating becomes lower, which is in this case a higher number, but it's a lower level, obviously 7, 8, or 9. Okay, now hopefully there will be no improvement mandatory. It means like if there is an improvement mandatory, it means your aircraft is need to be thoroughly redesign, perhaps in terms of flight control system, perhaps also in terms of the stability as well. Okay, right. So that is what you need to consider. I hope that should be at least for you to understand when you do the flight sim assignments. Now, you know that is only about pilot opinions, and then try to bridge that, or try to correlate that into numerical scale on the right there, so from 1 to 10. But of course, if you look at into the military standard, since we have seen already 8785C, you can see there is a metric standard that you could use as well, right? Now, you could use this when you do your flight sim. You could use this on top of the Cooper Harbor rating scale. I think it will be good to see your Cooper Harbor rating scale first, and then you try, if you want, you could try to also to correlate that with the military standard, metric standard used defined by the 8785C here. Now, obviously, the 8785C, for those of you who have you are designing the control system, I think if you were in my lecture note, if you read my lecture note, aircraft design, when you use this to design aileron control surfaces, obviously we talk about numbers there, where we try to assess the aircraft and then to try to sizing the aileron control system in order to achieve the, for example, level 1. We try to achieve level 1, which is the highest, the best handling qualities and flying qualities of your aircraft. Now, I'm not going to really talk about this in detail, but of course, I mentioned about you could separate independently between longitudinal and lateral stability. So when you talk about longitudinal, for example, I mentioned about the long period dynamic stability, which is termed as Pugoid, and then also we have a short period stability as well. Now in lateral and directional, where we try to couple them together, lateral and directional, there will be a spiral, Dutch roll, and so a spiral mode and Dutch roll mode, and then of course there will be rolling response or roll subsidence of your aircraft. But we're going to talk that hopefully in more detail when we go into in semester 2. But of course, for those of you going to go to level 7 later on, this is part of the stability and control module that you will learn in level 7 later on. But if you look at briefly now, I will put back again the table that you have seen perhaps in the aileron control surface design, in aircraft design. The same as that you need to 8785C military standard, usually then classify that your aircraft, you need to classify your aircraft first, whether your aircraft is class 1, class 2, class 3, or class 4. Then I guess we agree that your aircraft you design is obviously in that class, which is the takeoff mass greater than 30 tons, right? There is a class 4, which is obviously, this is something to do with the acrobatic aircraft, fighter, missiles and stuff. But your aircraft perhaps is in this fall into this class, which is class 3. Now, we have already discussed what sort of flight phase that you want to assess, whether flight phase A, which is, again, this is very detailed, precise task that the pilot needs to conduct, and the pilot and the aircraft need to conduct. You can see in 8785C, because being a military standard, that's related to, for example, air-to-air combat, ground attack, anti-submarine search, and so on and so forth, which is, again, if we talk about the commercial passenger aircraft, that is not something to do. That is not something that you want your aircraft to do, right? So, but of course, there is a very simple task, for example, like climb in flight phase B, climb, cruise, descents, for examples, and so on, which is obviously then you could consider that is the flight phase that you want to assess for your aircraft, for example. And then flight phase C is when you do a takeoff, approach, and of course a landing as well, right? So I think in aircraft design, when we try to assess or design the aileron flight control surfaces, I think I recommend you to look into the class C when you're do the approach, because obviously we want to have a sensitivity or to assess the sensitivity of your flight control system during the low speed. Because if you have a good sensitivity in low speed, hopefully when you aircraft in high speed, flying in fast speed, then it will not obviously it will cover that altogether. So that's why I think you could or you want to consider your aircraft or to assess your handling quality of your aircraft in flight phase C, for example. Right now. I'm not going to talk in detail about level. Obviously, the level 1 is the one that, in terms of design, is the level 1 that you want to achieve, which is the best, which is satisfactory. Level 2, which is considered acceptable, and level 3 is controllable. Now, when we talk about handling qualities assessment using 8785C, at some condition of flight, your aircraft could fall into level 2, which is still acceptable, right? So it's not really like it's not like the end of the world. Although in your design you try to achieve level 1, but at certain conditions, sometimes your aircraft go down in level 2 because you cannot. As a designer, later on you will understand that you cannot really satisfy all the flight phases, right? You optimize your aircraft during cruise, but it might not be good, or it might not be the best, behave the best during, say, climb, for example, which is you think that during climb, as long as it still can be considered as a good performance, acceptable, and then climb is only, as I said, takes about half an hour, maybe 20 minutes, 15 minutes, but the cruise, it takes like hours, 6 hours, 5 hours, that's why a lot of designers then try to optimize, optimizing during the cruise is the priority, because once you optimize the cruise, then probably that's the most saving money that you could do. If you could optimize the fuel, obviously, during the cruise, then you could save a lot of money there, rather than you try to focus on optimizing during the takeoff or during climb or during approach, for example, right? So when you try to assess your handling qualities later on, you may find that your aircraft fall into acceptable, which is still okay, because not all assessment will go into satisfactory. But of course, the design point you try to optimize, you probably would expect that your aircraft should give you a level 1 satisfactory. For example, if you try to achieve cruise handling qualities, obviously you want that in the level 1 satisfactory. Okay, now many of these metrics are related to the dynamic stability parameter. When we talk about dynamic stability, we talk about aerodynamic derivatives, right? We talked last time already about, for example, one aerodynamics derivative that very well known, very famous, to prove your aircraft longitudinal statically stable is Cm alpha, for example, right? Sorry, if I could just, this is really annoying. Cm alpha, which is turn into switch off, which is Cm alpha, which should be negative, right? And when we talk about lateral stability, Cl beta, if you remember that, should be also negative, right? This is the metrics that usually you can use in the, and then if you talk about Cn beta, which is your directional stability, should be positive, right? So this is very much when you design the aircraft, you want to make sure that this actually meets all the stability requirements for your aircraft. Okay, right. So now when we talk about longitudinal, I think I'm going to finish it in a couple of minutes or so, but hopefully we could continue to discuss this further in semester 2 when we talk about your flight sim assignments. But just to look into the longitudinal flying qualities or handling qualities in as defined by military standard MIL 8785C. I think I mentioned that the longitudinal dynamic stability, it has two modes. One is called short period and the other one is called long period or purgoid. Now you could then look into its damping ratio. How good is your aircraft goes into a convergent motion. And of course, that also related to the natural frequency, which is omega. Now, your damping ratio, which is zeta there for a short period, and your natural frequency, which is omega n there for a short period, you could then assess that or quantify that by using the aerodynamic derivatives. In this case, Z alpha, MQ, your speed, U0, which is initial speed during cruise, for example, and then your CM alpha, which is M alpha. Here is just CM alpha, basically, if you look at into the 8785C document. Okay, the same as when you try to quantify your damping ratio, you could use MQ, M alpha dot, which is CM alpha dot, right? DCM, I remember, if you remember, I always say that in mathematical expression, CM alpha means the change of CM due to the change of alpha dot, if we're talking about alpha dot, but CM alpha is the change of CM, which is the pitching moment, due to the change of alpha. Right? Now, you could quantify that, and then military standard 8785C define what level that your aircraft should be. So if your damping ratio, for example, bigger than 0.04 from this quantification, then your aircraft achieve level 1. If it is bigger than 0, obviously, but below 0.04, then it falls into category of level 2, but it's unstable, it goes into level 3, but that your time response, when you do the calculate the time response, it has to be bigger than 55 seconds, right? So then you can call that as a level 3. Okay, now there is other quantifications that you could look into the 8785C document standard, such as this, which is which I'm going to continue that in in semester 2, right? Any questions? I'm going to stop here, but I hope